Imagine being dropped into the most extreme situations you can think of, like right after a natural disaster or even on another planet. That's usually when people need the most help, but have the least time, resources, and options. So what do you do in a moment like that? Give up? Get angry at fate, the weather, or the space agency that sent you there? Or do you take a surprisingly elegant idea from an ancient Japanese art form and use it to literally print your way out of trouble? That's exactly the question MIT researcher Akib Zaman is tackling, and his answer is pretty inspiring. Drawing from the principles of origami, and more specifically Kirigami, his team has developed a way to create complex 3D structures that start out completely flat. These structures aren't just clever to look at either. They're what's known as auxetic, meaning they actually get thicker when you stretch them and thinner when you compress them, which opens the door to some really useful designs. Now think about what happens after an earthquake, a hurricane, or any major disaster. People need medical support immediately, not days later when supplies finally arrive. With the method Zaman and his MIT colleagues developed, it becomes possible to make things right on the spot. You can 3D print flat sections made of connected tiles, and with a simple pull on a single string or cable, those flat pieces transform into almost any shape you need. We're talking about splints, parts for foldable robots, dome-like shelters, and even massive building-scale structures. What's especially cool is that this approach isn't limited to just one manufacturing method. It can work with 3D printing, plastic molding, CNC milling for wood, and more. A multi-material 3D printer helps, since you need flexible hinges and rigid tiles, but the idea itself is surprisingly adaptable. There's even footage showing robots pulling the string to bring these shapes to life, and concepts for giant structures, where a crane would be needed just to pull the cable. Kirigami itself isn't new in industrial design, but previous attempts usually required complicated steps and specialized equipment. Worse, once you deployed those structures, folding them back down was either extremely difficult or just not possible at all. That made reuse and transport a real problem. The breakthrough from the MIT team is an automated system that can take almost any 3D shape and convert it into a flat layout of tiles connected by corner hinges. When you pull a single string, the whole structure inflates into shape. Pull it back, and it deflates just as easily. That means these designs can be stored flat, transported cheaply, and reused again and again, saving both time and valuable resources. What's really exciting is that these ideas don't have to be limited to dramatic disaster scenarios or space exploration. Even everyday problems can benefit. Take bicycle helmets, for example. A lot of people skip wearing them because they're annoying to carry around. A Kirigami-based helmet could fold flat and slip into a backpack, a briefcase, or a desk drawer, making safety way more convenient. Because size isn't a limitation here, designers can think big or incredibly small. This could lead to new tools, furniture, entire buildings, and even tiny injectable medical devices. The team is already looking ahead, testing things like hinge durability, cable thickness, and even self-inflating designs that could deploy automatically in dangerous or hard-to-reach places. So, while the future might not always fit neatly in your pocket, there's a good chance it'll fold flat enough to slide into a drawer, tuck under your bed, or lean against the wall of your garage. And who knows, maybe one day that garage will be on Mars.